Hello, grade 10s, and welcome. This is Mr. T. As always, it's a joy to have you aboard. In this video, which is the last video under our series on algebra, we're going to be testing our knowledge and understanding of the section algebra. I'm hoping that you've watched all the previous videos. If not, please watch the previous videos before you watch this one. In this video, we're going to be testing our knowledge through reviewing a past exam paper courtesy of the Department of Basic Education. This is a November 2015 paper. We are only looking at question number 1, which is the algebra section. 1.1. You are required to factorize the following expressions fully. 1.1.1, you're given x to the power 4 minus 81. At this stage, I'll ask you to pause the video, attempt to do the question yourself before you see the solution. Immediately, you should realize that the x to the power 4 and the 81 are both perfect squares. So you're dealing with a difference of two squares, implying that our factors would be x squared plus 9 in the first, and you're going to have x squared minus 9 in the second. Thereafter, you should realize that the x squared minus 9, the one in blue, there's a difference of two squares there. There's a difference of two squares. That means the final answer would be x squared plus 9 in the first factor, and you have two other factors as x plus 3 and x minus 3 as your second factor. I hope you got that one right. Let's move on. In the second question, you're given 6x squared y minus 10xy plus 15x minus 25. You've got four terms, implying that you could use factorization through grouping. How do you do that? Look at the first two terms, group them. Look at the last two terms, group them. In the first two terms, the common factor would be your 2xy. Then you're going to have 3x minus 5. And in the last two terms, the common factor is plus 5. You're going to have 5, then you have 3x minus 5. Immediately, you should recognize something that is common. That's your 3x minus 5, 3x minus 5. That's a common factor. If we factorize that further, our final answer would be 3x minus 5 in the first, and you're going to have 2xy plus 5 in the second. Alternatively, I would rearrange the original expression just to rearrange it, but apply the same principle. If I rearrange it, I'm going to have 6x squared y plus 15x minus 10xy minus 25. It's still the same expression. If you check the signs of all those terms, they're still the same. But what was the intention of doing that? It's just to do the same thing of factorizing the first two terms and the last two terms respectively. So the common factor now becomes 3x, and you're going to have 2x plus 5 in the first. Then in the last two terms, the common factor is minus 5. You're going to have 2xy plus 5 as well. Same thing, you identify that that's a common factor. And when you factorize it, you're going to get 2xy plus 5, and you're going to have 3x minus 5 as the second factor, which are literally the same factors that we got previously. We move on. If you look at that question, they say simplify the following expressions fully. You need to recognize what you're dealing with. In this case, this is an algebraic fraction involving addition and subtraction. Rule of thumb. Within each fraction, you need to try to simplify it if possible. Number 2, you need to simplify how, one might wonder, through factorization if possible. And there is factorization possible in this denominator, which is a trinomial, your a squared minus a minus 12. And if I do that, just to highlight that, I'll give you a note there to say factorize fully first. Then you're going to have 3 over a minus 4 plus 2 over a plus 3 minus 21 over a minus 4 and a plus 3 as the second factor. Now that we have fully factorized everything and we have simplified where possible, we now need to find our LCD, the lowest common denominator. And our LCD is evident there, that is a minus 4 and a plus 3. That's an easy one. Thereafter, you apply your knowledge of fractions from primary already. You would have done this. So the next expression, when you simplify, you're going to get 3 open bracket a plus 3 plus 2 open bracket a minus 4 minus 21 over our LCD. That's our a minus 4 and a plus 3. If you look at the numerator from the resulting one big fraction, you realize that there are brackets. We don't want brackets. We need to remove them. So we need to distribute. We're going to get 3a plus 9 plus 2a minus 8 minus 21 over our LCD. You always say over the LCD. Thereafter, you can still simplify that numerator by identifying your like terms. I'm seeing a 3a, a 2a, and constants 9, negative 8, and negative 21. So when simplified, that gives us 5a minus 20 over a minus 4, and you're going to get a plus 3 as the second factor. Then you take it further, you're going to factorize, you get 5 open bracket a minus 4 over our LCD a plus 3 as well. Question: one might say, why did I take that approach? It's because if you look at the 5a minus 20, there is a common factor which is 5. So I factored out that 5 and I took it that side, and I remain with a 5 open bracket a minus 4. And I'm seeing that I've got an a minus 4 in the numerator, I've got another a minus 4 in the denominator. That means those can cancel out each other easily. And what remains now as my final answer would be 5 over a plus 3. We move on to the last question. In our last question, we are required to consider the following numbers. You're given square root 27, cube root of negative 27, and square root of negative 27. Which one of these numbers is 1.3.1 irrational? Now you need to know theory to say an irrational number is one in which you cannot express as a fraction. In other words, if you're going to write it as a decimal, the decimal is not terminating. It doesn't have an end. So if you look at those numbers carefully, the only number which will result in a decimal which is not terminating is definitely square root of 21. Just to give you a side note there, I'll say it cannot be expressed as a fraction. You can take out your calculator, pull out your calculator, just say square root of 27. It will give you a number which has no ending. All right, then we move on to the very last question. Of those numbers, we're asked to identify which number is a non-real number. Your understanding of the term non-real, it is a number in which it falls under a square root sign and it has to be negative. And if I look at that, there is square root of negative 27. One might say, what about cube root of negative 27? No, cube root of 27 is actually a real number. How is that so? Because the answer is negative 3. But for square root of negative 27, the answer will be undefined. It's non-existent. So the final answer there is just square root of negative 27. I hope you enjoyed this lesson and this series. It's been a pleasure having you. Signing out, this is Mr. T. Bye-bye.